All right, welcome back to Lag Demon Programming. I'm Bill Westlake, and this is the compiler design course. In this section, we're talking about multi-threading and how to handle threads in a reasonably correct way. There are various ways of handling this stuff. This is the way I like to do it. Other people may have different opinions. That's okay. Now what we're going to do is take these ideas that we've had here, and I'll go over them real quick. We talked about using lock guards to prevent both race conditions and using them in an appropriate way so that we don't create deadlocks. And that's by having them automatically destroyed when it leaves the particular scope that it's defined in. This is how you define a scope, you notice it doesn't need to have any statement around it. It's just a scope within this while loop that says that every time this exits this scope back into the while loop to come back around, this is destroyed, and therefore it is unlocked and allows the next one to pass through it. So what we're going to do now is create a new file, and we're going to call this message thread.hpp. Now, I've used a lot of .h files for this kind of stuff, and I think I may change that around a little bit just to allow the compiler to understand that this is actually a C++ file and not a C file. Some of the IntelliSense problems I think I've had with using .h is that Visual Studio Code, I noticed, thinks that the header file, when you call it just .h, is a C code file, so it gets confused about the C++ for some reason. So I'm going to do that. We will put our typical guards around this, and we'll go underscore message thread underscore HPP. Define that. So the first thing that we're going to need in this, well, we need some includes. We're going to need thread. We're going to need mutex. Did I type something wrong? Yeah. We are going to need, let me look at my notes, make sure I get all this stuff. We're going to be using a queue. We're going to be using the functional library. I'll talk about that. I don't think we've used that before. We're going to be using vector, and we're going to be using conditional variable. All right. So the first thing that we're going to want is we're going to create a template class, and the type is going to be the message information that we want to pass for this, and we're just going to call this message. And this is going to be the class that we're going to pass around as the messages for our system. So we'll have a private, this is our actual message, underscore message, and then public. All right. Now, we're going to create a number of constructors here that are important. We want to be able to create one of these classes with a message, and we want to be able to copy them and move them and assign them because they are messages, and they're kind of like our version of a low-level data type. We want to be able to do these operations on them. So just to avoid a little bit of typing, save a little bit of time here, I'm going to copy paste these in and then explain them because it's a lot of kind of boilerplate typing. So we have the basic constructor of a message here. It takes a T message type and it assigns it to message. Simple. Okay. Then we have a copy constructor. It takes a constant message reference and it assigns the internal value to the object that we're constructing with the copy constructor. And it also has a move constructor. This is a little bit different. This double ampersand here is a special kind of reference. I will talk about that at a later time, but just know that what this does is it allows us to move the information from one to another. Okay, and that's called a move constructor. And then we have an equal operator, which is an assignment operator that assigns one object to another object. And then, of course, we need a getter. So we have T message, get message, and we'll just return underscore message. And that's it for our message class. We can pass these around and use them. Now we're going to create a thread class that handles, a message thread class rather, that handles a particular type of message. And there's a couple of ways that we can do this, but I'm going to do it this way. We're going to do a type name, T message, and this is the actual message type. Class message thread. I'm having a little trouble typing today. We'll have a private section, a public section, and we're going to have a protected section. All right. In the private section, we've got to create a number of items. Again, I'm going to copy paste these in and explain them, just to save a little bit of time here so we can move forward and get to testing this and playing around with it. So we're going to have a queue that takes a message of the type we specify here. Now understand, this message can be part of an object hierarchy. It can be a T message, can be a base class of object hierarchy. So this thread can handle multiple message types as long as they're all appropriately part of this T message type in some way. So we're going to have a queue, and this is where we're going to queue up the messages that come in. We're going to have a mutex for guarding our updates, and we're also going to have a mutex for waiting for an incoming message, and those are used slightly differently. And then we're going to have our thread that's going to keep things running, and we're going to set a Boolean value here running for now. We're not going to do anything directly with it, but eventually we'll have a way of sending a special shutdown message to these to tell it to stop the thread. And we'll work that out as we work out the system a little more. But I'm putting that in there for now so that we have a way of just setting that. When we come to it, we can set this to false and signal it, and it'll see the false, and it'll just exit the thread. That'll give us a nice clean way to shut these down. We'll have a condition variable. I'll explain that when it comes up to using it, but a condition variable is something you can wait on, and when it gets signaled, it allows the thread to move forward. And then this vector is our subscribers, and here we're using from the functional package a function, a way of defining a function that takes a message, and this is the way we will subscribe to this. So then we have a message thread, and actually our constructor, our main constructor here, takes no arguments and starts up the thread, but we want to do a couple of other kinds here. We're going to do a message thread that takes a constant message thread ampersand equals delete. We don't want to copy these threads. And then we can have message thread, message thread ampersand operator equals, let me take a look. constant message thread ampersand equals delete TED equals delete. So what we're saying by doing those two things is this is going to eliminate the default constructors for these, making it impossible to copy, move, or assign a thread to another object. We don't want to do that because we don't want to allow that to happen, because a thread is an operating system resource and we don't want to be copying it around and using it the same exact object in multiple ways. Under protected, we'll get back to the public section real quick. We're going to have a function called run, and for now I'm just going to leave that empty, but we are going to put some code in there, but I want to have it in place as we start creating these other parts. So and that's why I put it down here, is that it's right here. So when we create this thread, remember before I just put the function name in, now we have to tell it where that function's coming from explicitly. It can't just be the function name. We got to tell it the address of this run function here, and that it's this object that we want it to run on. So it's going to find that function, and that this pointer tells it that it's on the instance of this object that we want that thread to run. So that should start up that run thread. We got a couple other functions that we need to do here, but for now what we're going to do is build up this run function first, and then we'll add the other functions in first. So what are we doing here exactly? Well, we're going to say while underscore running. All right, this loop will run continuously, and like I said, we'll figure out some clever way to be able to send a specific kind of message to this to tell it to stop running. In fact, we might add a type here at some point in time to do that it'll be able to look for. We need to set up a kind of lock, and this particular unique lock is for our waiting mutex. And then we can wait for that condition variable to be flagged. So what we're going to do is go standard unique lock of type standard mutex, and we'll just call this LK. And the mutex we're going to use is our waiting mutex. So nothing else is going to use this waiting mutex except this little part right here. And now we're going to do waiting for message, which is our condition variable, and we're going to tell it to wait. And we're going to pass in hold on one second. Yeah, we're going to pass in the lock to that. So now what's going to happen when this starts up is this thread isn't going to be doing anything. It's going to be waiting on that condition variable being tripped, and I'll show you how we're going to do that later. Now we're going to do exactly what we did before and just create a scope. And in here we're going to do a standard lock guard, standard mutex lock underscore mutex, and this is our main mutex that we're locking. We're going to use from other functions to lock this. Now the reason for locking is we're going to be talking to our state. So we're going to ask, is the message queue dot empty, or rather is it not empty? So while the message queue is not empty, we're going to process any messages that came in before we got the wait signal, and we're going to see how we can actually queue up multiple messages at some point here. So what we want to do is get that message. So the message is going to be from the message queue, and we're going to get the front of the message queue. So when we add messages to it, we're going to push them, which is going to push them on the back. So we're going to be first in, first out. We're going to keep the messages in the same order, in other words. So we're going to pull them off the front as we push them onto the back. Now we've got our subscribers and that are going to be able to subscribe to this. So what we're going to do is loop through those subscribers, and we'll just call this sub in underscore subscribers, and we will just call sub message. So we're going to pass that message on to all subscribers that way, and that's it. That's our main run loop for our thread that's going to handle incoming messages and pass them out to any subscribers. So, so first things, how do we send a message? Well, let's create a function called send message. Message, tMessage, message. We're going to come in here and create a scope. We're going to go standard lock guard, standard mutex, lock underscore mutex. This is that main mutex. Then we're going to go message queue dot push message. So the reason for the lock guards is so that we're not pushing a message while this is trying to read and pop out all of the messages. Oh yeah, we forgot something. After we get it off the front, we want to go underscore message queue dot pop. We want to get that off the front of it. So this way, these two are coordinated by this mutex, so that when we're queuing a message, and we're going to have a system in for queuing multiple messages as well that we may want to send, or if there's a bunch of different threads lined up here that are going to scoot through this faster than this thing can scoot through the lock guard, it's going to not confuse the queue, pushing and popping on different threads. Now the thing is when we actually do that, once we come out of the lock guard, we want to go waiting for message dot notify one. So this will tell it, yeah, I'm done pushing the queue, you can go ahead and run, and that'll trip this waiting for message dot wait. By calling this waiting for message don't notify one, it'll tell this thing to move on, and it'll start running this code on this thread. So this is a different thread, and this is a way we're notifying this thread you can go ahead and run. We're done updating the queue. All right, so now we need a subscribe, void subscribe, and we're going to pass a function in, and now we're working in that functional include that we put in, and this is the way we create a function. We're going to have a void return value, and then we're going to have a message of type T message that we're going to allow to be passed in, and this is going to be our subscriber. So this is going to be the function subscribes to this, And because this thing here might be accessing that subscribers loop, we're going to again create this scope and create this standard lock guard of type standard mutex called lock. And we're going to pass in the mutex that we're using to coordinate these two threads. And then we're going to do subscribers dot pushback the sub. So that allows us then to subscribe to it and not interfere with this loop. This will have to finish first before we can subscribe. That way we're not messing with that subscribers vector while this thing is looping through it, which could confuse things and cause problems. And finally, we need a way to join this thread, and we'll just call it join. And what we'll do is just go if underscore thread dot joinable underscore thread dot join. Very simple. And that's our class for handling messages. Let's test it out. So we'll go back over here to threads.cpp. I'm going to go here to this main. I'm going to do my usual thing of tripping that out. We'll create a new main function, int main void return 0. So we want to create a message thread. Oh, we got to include it. Message thread. And we'll just we'll just make our message type very simple int, and we'll call this what did I call it? That's too long. Message thread. So now we'll go message thread dot subscribe, and we can pass in a lambda. So we to make a lambda, we need a capture list, and we need a parameter list, and the parameter list is going to be of type message int, and we'll just call it message. And then we have a function body, and we can end this statement. And here's our oops. So here's our lambda function body. Why doesn't it like that? Message int. This may be nothing more than let's see what it says. It doesn't like it. Template argument is invalid. Alright, we see what did I do wrong. Standard function void message. Oh. Yeah, the syntax on those gets a little bit screwball. Operator equals constant message ampersand. Oh, yeah. So this has to be, we got to put the template types in here. Message thread, message thread. Let's build this. What doesn't it like now? Constant T message ampersand. What doesn't it like? T message. Message. Constant. Message. Oh, I forgot this again. Still doesn't like it. Oh, I spelled this wrong. There we go. Okay. And now it still doesn't like it there, but it seems to like it okay. Oh, it finally went away. It was because of those other errors. We're running about 26 minutes into this. Let's see if we can knock this out real quick. Threads. What we'll do here is we'll go message int. No, what we'll do is we'll go, I'm going to copy paste so that we can get this moving along, get this video done with, and I'll explain it real quick. We'll just do this, but I got to change a name here because I didn't do the same thing. This has to be this, and then we want to join it, but it's got to be this. Oops. It's got to be this. Let's see if this builds. Message thread dot. I used a capital. Dot slant threads, and it looks like it's not wanting to work. What did I do wrong? Sub I. Let me go back and check this. Did I do this right? Did I signal it? Yes, I signaled it when we got a message. Lock waiting, lock mutex. We probably don't actually need this. Let's see, why are we terminated call? Yeah, we do need that. Why isn't it printing out this got message? We subscribed for Oh, I know why. I'm coming in a little too fast. We'll tune this up and figure this out. We're going to put in a little delay here, just so that we don't start sending messages until the thread actually starts up. And there, it got the messages. It passed them on. It called back to the subscriber. We can subscribe a second time with another one. We can do this, and we can go second sub. And we run it. Let's see, we got second sub got message 90, second sub got message 90, 91, 92, 95. Yeah, they're all coming through correctly now. So the reason for this slight delay here is because this thread's got to have a little time to start up before you start calling it. So what we will probably do is put this, we could actually put this in the constructor, and we could trim that down a little bit and see if we go over here to message thread, come up here to the constructor, we could probably put this in here, and let's trim that down. Let's give it 10 milliseconds. So when the constructor runs, it's going to create this, and then it's going to drop into this delay. So let's see if that allows us to run. So that allows us to run 1 millisecond. 1 millisecond was enough. We take it out. It won't be enough. We'll crash into it too quick. Yeah. So we need this just a 1 millisecond. All we need is a 1 millisecond delay. That's not too bad. And just to give it time to start this thread before we start calling on it and locking on it and so forth. So anyway, we're 32 minutes in. That's it for this video. Thanks for watching. I hope you enjoyed it. If you liked the video, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video. Thanks for watching.